Okay. Okay, please confirm if you can see my screen, if you can hear me properly.
We can see your screen, sir, and we can hear you.
Thank you very much. Okay, so today we're going to do a few things. Please don't forget to submit your assignment because I need to check if you're studying, where you're struggling, because you need to be very good. Okay, so I come here. So we did chapter 1, 2, 3 already. 1, 2, 3, 4. Yeah, so now we're going to do, let me check what's that. Yes. Yes, so we did 1, 2, 3. Now we're going to do chapter 5 and 6. We are very short. So I open here. So before we do chapter 5, I want us to continue with chapter 6, data link layer. So last time we did study the OSI layer. The OSI, so when we have a network, how are we going to classify everything? How are we going to classify? So we have two ways, two models. If it's TCP/IP, we have 4 layers. The most used is OSI, where we have 7 layers. And last time we did check that for physical one, for layer 1, the physical layer, it deals with the media and the cabling. So anything relating to connectivity, cabling, we classify them in layer 1, the physical layer. So anything related to UTP, STP, to network cables, anything related to wireless, anything related to the fiber, we classify them in the physical layer. So today we're going to do the second layer, data link. We're going to do the data link layer. So for the data link layer, we have anything related to the switch. Anything related to a switch is what we call mute. So Esther, can you please mute yourself, please? Thank you. So anything related to a switch, we classify them in layer 2, data link layer. And for layer 3, anything related to a router, we classify them in the network layer. Please mute yourself if you're not talking, if you're not answering any question. Thank you very much. Okay, we continue. So we did physical layer last time. Today we're going to do layer 2 with data link layer. Anything related to a switch. So last time I did show you a Cisco switch. Cisco switch. And so if I take, there is no, okay, if I take this one, for example. So a switch is a device that will connect all the PCs will get connected to the switch. All the PCs will get connected to the switch. So each port on the switch is connected to a PC. So we have two types of switches, like the link I did send you this morning. We have what we call a managed switch, and the other one is unmanaged switch. The unmanaged switch is very simple. Just plug in that tool. You cannot manage, you cannot configure, you cannot do anything. You plug a network cable, that's all. But this guy here is called a managed switch. And it's what we will use a lot because you can do configuration, you can do some security, some SVI, and a lot of stuff. So we have two types of switches: unmanaged, very cheap, we don't need to configure anything, and we manage one like this guy. So each port will get connected to a network cable to a PC. And what type of traffic will go through this switch? The traffic is called frames. Some frames, so I'll show you later. So the data link layer consists of two sub-layers. The frame, so remember, when you have your PC, you tap your email and you press send, it's your data. So it will go down to the presentation layer, session. At the transport layer, your data name, because the transport layer will add some more info on the data. Then it will get called the segment. Then the segment will come down to the network layer, and the network layer will add more info on the segment. Now the new name will get what we call the packet. So when the packet reach down to the data link layer, the data link layer will add more info, like the MAC address or the physical address of my PC and all this stuff. So from here, the data is called now frame. Now the data is called frame. That's why at the data link, the name of the information the switch will deal with will be the frame. I'm going to show you an example of frame. We did chapter 4 already. I'll show you chapter 6. I'll show you what a frame is. So in that frame, we'll have three parts. We have a normal data and other info connected to that data. So we'll have what we call LLC, logical link control, and we have the MAC address, media access control. So the LLC sublayer communicates between the networking software at upper layers and the device hardware at the lower layers. The MAC sublayer is responsible for data encapsulation and media access control. So the LLC will deal with communication between, so we are here, it will manage links between the network. When the packet will reach the data link, the LLC will welcome and make the treatment. And when it's time to go to the physical layer, the LLC will do also some treatment and send back to the physical layer. The MAC address is going to add more info, the MAC addresses on the frame, so that the frame will be able to go to the media and go to the destination. So 1 minute quickly gets, you can read this, you can copy my screen if you want to for your own revision, and we continue. So this is what chapter 5 will be. So last chapter was about the physical layer. Then we went back to the data link layer. Remember what we're doing when you have a network, how to classify everything you see, everything you deal with. So we did the physical layer, anything related to cabling, wireless, fiber. Now, layer number 2, the switch. And in the switch, the information the switch will treat, will manage, will process is called the frame. And inside the frame, we have the physical address or the MAC address. So I'm going to show you an example of frame. I'll show you an example of frame. Yeah, this is an example of a frame. You see that your data that comes from the top is still here. And at the frame level, this level will add more info, a header and a trailer. Now your packet is now called a frame because of this element, this component you added. So in the header, we have the frame start, addressing, MAC address, the type, control. Your data is still here. Now in the trailer, we have error detection. Is the frame in good health? Is it good to be processed? And where the frame stops. So please have a look on this, on the frame, then we continue. You can also copy the screen, open a Microsoft Word document, paste, and to make your own summary for your own revisions. Okay, we continue. So I try to make it very simple for you. So that when you go back to NetAcad, you will the last time. Now we deal with the layer 2, with data link. Anything related to the switch. The component, the element, the switch will process, the data is called the frame. The frame is something like that we just saw now. Okay. We continue. So in the switch, you must know the LLC, what the LLC is, and the MAC address. So if you know this, that's all for chapter 6. That's the main thing you should know. So in NetAcad, we'll add more info, but the main thing you should know is this. So please, again, copy the screen, paste your Microsoft Word document for your own revision. Then I'll quickly go back to the PowerPoint and show you extra info. Okay, so normally we are done with chapter 6, but let me go in the PowerPoint and check if there is more info, or maybe in the chapter 6 is here, introduction. So why the data link layer is important? The data link layer of the OSI model, layer 2, will prepare network data for the physical network. It means what? Now your data has reached, has left the application layer, go to presentation, go to this session, to transport. Now it reaches here. And now here we have a media, all the cabling. So the data link will prepare this section to be put on the media, on the network cable or on the wireless. So the data link will prepare that interface card to network interface card communication. So this is what the data link also will do. So let me add this student in. Yeah, so quickly have a look on this and continue. Anytime you have questions, please feel free to ask. So this is what the data layer. So when you tap your email, for example, and you press send, it will leave your PC, and before it goes to the network cable to go in the background, when you press send, it will leave your application, your Gmail, go to presentation, session, transport, network, and before it goes to the network. So as I said last time, a data to leave your PC to reach destination, we have two main parts. The logical address or IP address, source IP, destination IP. So we have the logical address or IP address, and we have the physical addresses. Layer 2 is physical address, MAC addresses. Layer 3 is IP addresses, we'll do later. So without these two, your packet will not know where to go. It's like you want to send a letter to someone in, let's say, in Belgium. The post office will need the recipient address. Where should we send your envelope? Is it in America? Is it in Canada? And in case we cannot process your to the destination, and in case we cannot send that letter and we have to return to you, you must also, that's why we have source, you the sender, your information, and the destination, if you want to send a letter to your friend, the destination address, physical address, and destination IP address. Without that, the post office cannot send your envelope, your courier. So it's very important. So layer 2, MAC addresses, layer 3, IP addresses. This is an example of IP address. And the MAC address I did show you last time. I can still show you. CMD. And here, you type IP config space / all be present. And here, which, because I'm using my Wi-Fi, I read from here only. This is my physical address. So when I send a data, that address is included in that data. So the physical address is here, or MAC address, and the logical address or IP address is here. So these two are needed for your PC to communicate with other people. Okay, after that, we have a lot of information. So here, I will explain more what is LLC and the MAC address. You can read, not too much important. So the data link layer is here. We have two parts. LLC will treat the data coming from the network, will receive it, work on it, then send to the physical layer. The MAC address will make sure that the data will go to the physical, to your cabling, and reach destination. So we have more explanation here, so you can check that. Okay, what is this one? So your packet is inside. Okay. Data length standards. Okay, you have some standards, not too much important. What is in topology here? Okay, we did check the physical topology, how physically you're going to organize your PC on the table, your printers. Physical topology. Then we have a logical topology, the data that will flow in the network cabling, the IP addresses, something you cannot touch, you cannot see, is called logical. When you assign IP address, you cannot touch, you cannot see. When you press send and the data flows in the network, you cannot see. So logical will deal with IP addresses, MAC addresses, all these things. One topology, okay. How if you have an office in Cape Town, an office in Durban, an office in Pretoria, how are you going to connect them? You can have a router in Cape Town, link to a router in Johannesburg, link to a router in. So it depends what topology you want. If it's two offices, you just link the two routers, it's fine. If you have a lot of money and you don't want anything to fail, you can do such thing. But usually it's either this or this we use. Okay, physical topology in a LAN, the most used is the star, where all the PCs are connected to a switch, and we switch to the router. In the old days, we had the bus topology, but we don't use them anymore. It's the star topology, where all PCs are connected to the switch, and we switch to the router, and the router to internet. Half duplex and full duplex. So here you can see that I'm talking to you alone. So it half duplex. Like we have only one lane and you're driving. There are people who want to exit and there are people who want to come in. We only have one lane. So everyone will stop. If the lane is free, then I can use. We cannot go together. So half duplex is communication in one way only. I talk to you, I stop, you talk to me only. We cannot talk together. Full duplex, we can talk together. We have, on the road, we have two lanes to go and to return. So full duplex, the media, your network cable can send and receive data at the same time. Half duplex, not. So nowadays, we use full duplex, where you can send and receive at the same time. So half duplex, you see, we cannot communicate at the same time. We call it half duplex. Full duplex, you see, we can send and receive at the same time. Job interview, we can ask you such questions. And next assignment, I'll make sure that question is there. What is the difference between half duplex and full duplex? Okay, anything here not too much important? If I say not too much important, for me to teach you yourself as a student, you go through it. If you think it's good, you put it in your summary. Now there is something called CSMA, CA, and what. So if you have a network cable, so how the network cable will know that the lane is free so that you can send, or you have to wait to receive first and send. So the system that will manage, that will control, that will listen to the media is called CSMA-CD. CSMA-CD, it will be the system of a protocol that will listen, that will listen. Can you still see my screen and hear me? Let's think. Okay, 1 minute. So a system that will listen to the media to check if it's free. Now you can send, or just wait. Someone is coming. It's called CSMA-CD. So it will listen to your network cable. If it's Wi-Fi, so the CSMA-CD will be the system that will listen to the network, to the media. If it's free, you can send. If it's not free, you wait. Only for half duplex. Because full duplex, you don't need to wait. You can send and receive. So this one is for network cables. If for Wi-Fi, it's this one. So you can have time and to read all these things. Now the frame is the name of that data the switch will process. So we have a header, the data, the normal data, and the trailer. It's like a visa. I'm going to add visa on it. So this is an example again. You can have a look and continue. Okay, you get time to read that. Layer to address. Yeah, so it's very important for data to leave, to go, we need the two addresses. So if you capture a data between the user and the router, in the data, just one second, please. Okay, another thing to know, if you capture a data between the user and the router, the source IP is me, and my destination IP is where I'm going to. So source IP and destination IP will never change when the data is traveling. What will change is the source and destination MAC. So if you grab a traffic between the user and the router, the source MAC will be me, destination will be for the interface of the router. If I grab a traffic between the router and router 1 and router 2, source IP, destination IP never change. That will change will destination NIC and source NIC. Source NIC is the interface of R1, destination is interface of R2, and so forth. We will have time also to manage that a bit later. And what else that's more important? So that's all for this chapter. What a switch is, at what layer. In that layer, we have two sub-layers. So data link, we have a switch, and we have two sub-layers. Each of them, they have their own way to work. And the frame is that element we find at the switch. So now let's quickly do chapter 5. So we did chapter 6. It's about the frame, the data link layer. And we're going to continue with chapter 5. And on Monday, we'll do chapter 7 and 8. It's only theory for now. That's why I said, please practice a lot your packet tracer and submit. CCNA1, the first part is called Introduction to Network. We are preparing you. You did the IT essential to get an idea of everything in IT. Now, in CCNA, we have 3 parts. Introduction to network, step by step. In a company, you should be able, everything we teach you here is exactly what we do in a company. Monday, we'll do chapter 7 and 8. We are very short also. Wednesday, we'll do addressing resolution and basic router configuration. And Saturday, we'll do IPv4 addressing. If you have some labs, I will do some demo for you and you can practice. So normally by end of this month, you should have finished with theory. Then we do revisions with some packet tracers, some practicals. Friday, 26th of July, we all meet at Scalabrini. Please bring all your laptops, everything. We're going to do some practical stuff with packet tracer. All questions you have, anything you didn't understand, you can either send me via WhatsApp with some videos, or you can post in the group. But the 26th, I will double check for everyone, make sure that you understand properly. So please don't miss 26 at Scalabrini. So we continue with chapter 5, the number system. It's very simple. Do I have something here for numbering system? So remember also at the physical layer, we did the name of the element we find at the physical layer, we call the bit. So we have the layers here, our layers, and the name of the element we find, we call packet data unit, PDU, packet data unit, or what is the name of what we find. We have our normal data. When it reaches the transport layer, that data is called now a segment. Why? Because on our data, the transport layer did add other info. So now it's called segment. When it reach network, this layer will also add some stuff on it. It will get called packet. When it comes to data link layer also will add some stuff. We call it frame. And at the physical layer, we call them bit. So this is what we call bit. Bit is either 0 or 1. And if you have 8 bits, we call it a byte. So who want to join? So please check this. If you want to copy my screen to paste, feel free to do that also. So for your next assignment, I'll ask you the question, what is the difference between a bit and a byte? So the answer is what? A bit is a digit, the digit 0 or the digit 1. The byte is a group of 8 bits. We call it a byte. So everything we do is what an IT guy should know in. Okay, there is no numbering system here. Let me check. Okay, it's this one, numbering system. Yeah, this one is numbering system. Okay, quickly, let's go there and see what we can check. Numbering system, we come here, data link numbering system introduction. Okay, let me check and make it simple for you. Okay, numbering system, it's something like, how are we going to count? Some people will say we count in fives, 0, 5, 10, 15, 20, you see, and you continue. And we say base 5. It means we count in fives. Some people will say it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then after that, we have 20, 30, 40, you see. So there's one called base 10. It's what us human beings we use, base 10. And you have the pieces. We understand only 0, 1, 0, 1. And this one is called base 2. So machines, we don't understand our numbers, 20, 40, 9, no. They understand 0, 1, 0, 1, 0, 1, the bits. We also have another system. It's 0, 1, 2, 3, A. It goes to A, B, C. So this one is called base 16. And mostly for MAC addresses. So in this chapter, we're going to convert base 10 in base 2 for the PCs to understand. After that, if you have a MAC address, base 16, how to convert in base 2 for the PCs and for the system to understand. It's what we're going to do. So I'll try to make it very simple for you. So we have a video, we'll explain base 10, base 2, and how to convert. But I'll try to make it very simple for you. Convert binary, the machine to decimal for us to understand, or decimal for us human being to binary. I will try to make it very simple for you. So I check here, I check, okay. Now this one is hexadecimal for the MAC addresses in IPv6. So we'll have decimal, you see, then the binary and the hexadecimal. You should know this table. It's very simple. When you see like that, it might be scary, but it's very simple. I'll try to make it very simple for you. So I'm just checking what is in here, and also have videos where they do the conversions, they explain everything nicely. How to convert between hexadecimal, decimal, and binary. Everything is well done here. And that's all for this chapter. How to convert stuff. So let's make it simple for you guys. Convert decimal 82 to binary. Convert 82 to binary. Binary, yes. So it's very simple. So check this. I'm going to show you now. Please confirm if you can still see my screen and hear me properly before I start.
We can see your screen, sir, and we can hear you.
Okay, thank you very much. Guys, it's very simple. So if you want to do your conversion decimal to binary, we have what we call a table. Insert table. This one also I'll give you for next assignment. And in that table, you put 128 divided by 2, 64, divided by 2, 32, divided by 2, 4, divided by 2, 2, divided by 2, 1. So this is my table. Now I put my 82 here. Because we need to convert 82 to binary. So I check 82. In 82, I need to do what plus what plus what. So I need to use all these numbers, some of them, to combine them to become 82. So I start 82 minus what? So you can see that in 82, I cannot deduct 128. No. So 82 is smaller than this one. So 82 is bigger than 64. So if I do 82 minus 64 is equal to what? I take my calculator. Oh man, why is that typing? Spring my calculator. Yes. You see, 82 is bigger than 64. So I can deduct 64 in 82. 82 minus 64 is equal 18. I put 18 here. Then I go down. In 18, I need to deduct what? 18 is bigger than 16. So 18 is not bigger than 32, no ways. It's bigger than 6. So it means in 18, I can remove 16. 18 minus 16 is equal to 2. Then I come down here. 2. 2 is fine here. 2 minus 2 is equal to 0. It means in 82, I took 64. I put it in red, in bold. I took 16, and I took 2. So if I take back my calculator and I clear everything, if I say my 64 I took, so here, so 82 is what? 64 plus the 16 I took plus my 2. So you see now. So if I take my calculator and I clear everything, if I do 64 plus 16 plus 2, 64 plus 16 plus 2, you see now it's 82. Now that we did, and we check here, so 64, if I took 64, I put 1 here. I took 16, I put 1 here, and I took 2, and I put 1 here. Anywhere I didn't use, I put 0. Put 0, 0, and 0. And now I come down here. I say 82 decimal 82 is equal to, now all these numbers, you write them down here, equal to 0, after 0, 1, then 0 again, then 1, then 0. So for us human being, we understand 82, but for machines, we understand this one. So if you take 0 times 1 is 0, 1 times 2 is 2, 0 times 4 is 0, 0 times 4. So check this, and if you have questions, let me know. Else, in 1 minute, I'll give you a second one. You do yourself, and you let me know. If you have questions, just unmute yourself, tell us your name, and ask your questions.
Hello, it's Denise. Yeah, I wanted to know, sir. Anytime they
Yes,
give you a
Denise?
number, you must anytime you get a number, so you must deduct up to 0, up to get 0.
Yes,
Okay.
up to you get 0 here.
Okay.
So you can copy my screen, paste in your Microsoft Word document. Anyway, it's recorded. You can still watch on YouTube. And also in NetAcad, you have some videos. They explain also how to do that. So this is an example. This is something else for you. Then you can do that. Convert decimal 127 into binary.
Papa Max,
So you do the same thing. Yes.
can you hear me?
Yes, question? Yes,
Yeah,
what's your
it's
name?
Amy.
And you tell you ask your question. Yeah,
It's
Amy,
Amy.
yes.
Yeah, Papa, just want to know where did
Yes,
you get
Mama
that
Amy. Yes.
one? Yes, Papa. I wanted just to know where did you
Where?
get that 128? It depends with a number that they will give you. You will also get those numbers, or where, because I saw you start with 128. I just want to know where 128 came from.
Okay, very good question. Me, I like any type of questions. Feel free to ask any type of question. Your question will also help us. Thank you very much for asking. So when we have to convert decimal to binary, so it's a rule, it's a table. So you start with your table. You put your table like that, then you start doing your stuff. So, and let me do this one for you again, then I'll give you a third one, okay? So here, they want us to convert 1 to 7 in binary. So first thing first, you do what? Your table. I'm going to copy, okay, you do your table. If you need to convert, and your table, you start always with 128. You see? After that, you divide by 2, 64, divided by 2, 32, divided by 2, 16, divided by 2, 8, divided by 2, 4, divided by 2, 2, divided by 2. Sorry, I made a mistake here. Now, 64 divided by 2, yes, 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 yes. Okay.
Sorry, sir.
Yes.
Why do you start
Yeah,
with
tell us your name and
128?
your question.
It's Sangani.
Yeah, it's the rule.
Oh, it's the rule. Okay.
Yes, Sangani, it's the rule. Yes, it's the rule. It's like you asked me the question, sir, why 1 plus 1 is equal to 2? Hey, my brother, I cannot help you. It's the rule. You see, 1 plus 1 is 2. So it's the rule. And always you make your table like that. You make your table. My stuff is hanging here. So after you make your rule, your table, so I can explain a bit why they do that. I don't want to confuse you, but I can show you. It's called the position. The position I'm going to show you. I'm going to show you. Let me see. I want to make it very simple for you so that you won't. So it's here, but I don't want to. Okay, let's make it very simple. Just so position is because it's binary. I'm going to make it simple for you here. Insert table. Table. Why doesn't want to insert? Yeah. So here I put position. The position. Position 0, position 1, position 2, position 3, 4, and 8. Position 8. Power. So position 0, it means 2 to the power of 0. 2. If you did mathematics, that's why I didn't want to. What is that thing of power here? Okay. 2 to the power of 0 equal to 1. Equal to 1 here. If you take your calculator, you go to scientific 2 to the power, you see, of 0 equal 1. Here, 2 to the power of 1 is equal to 2. 2, because here we deal with binary. Binary, it's base 2. So remember, base 2 is binary, 0, 1, 0. We have only two numbers, number 0 or number 1. That's why we say base 2. We understand only two numbers. We understand number 0 or number 1. So it's only two numbers. That's why we say base 2. So if you use that base 2, you see 2 now to the power of 2, it will be 4. 2 to the power of 3. If you take your calculator, you clear everything. 2 to the power of 3 is 8. You see, it will be 8. 2 to the power of 4, it will be 16. You see, until you find your stuff. You do the same thing. This is where that thing comes from. 2 to the power of 6. 2. What's that? 2 to the power of, sorry, here is 6. Here 2 to the power of 7. 7 is here. You put the same 7 here to 2 power 7. 6 is here. 2 to the power of 6. You see, and do the same thing. 2 to the power of 5. 5 is here, and put, you see. This is where our 12264 comes from. So if you go in NetAcad, you'll see that. So when you have to convert decimal 127 to binary, you do your table, that 128 divided by 2 until you reach 1. So after you do your table, so Sangani, are you okay now? Sangani and Mama and me.
Oh, good, sir. Thanks a lot.
Yes, Papa, I'm fine. I'm fine.
Okay, cool. Okay, cool. So now we have to convert 127 into binary. It means 127 will be what plus what plus. So we need to take a combination of these numbers. Okay, let me change to to 200 to 204. Yeah. 204. So we need to combine all these numbers to become 204. So you start 204. Is it bigger than 128? Yes, it means I can remove in 204, I can deduct 128. See? So you take your calculator, be careful, very careful. If you make a mistake here, your machine will get lost. That's why it's done automatically in the system. 204, let me go back to standard. 04 minus 128 is 76. Then I take that 76. I must deduct what? So in 76, you cannot remove 128, no. But in 76, you can remove 64. Is bigger than 64. So 76 minus 64, 12. So 12 is bigger than 8. So 12 is not bigger than 16, no. 12 is bigger than 8. So I put here 12 minus 8 is equal to 4. Now I have my 4 here. 4 minus what? So 4 is equal to 4. You can see that 4 is not bigger than 8. So I deal with this one. So 4, I can say 4 minus 4 equal 0. It means I used this. I used 64. I used 8. And I used 4. So then I put them here. So 204 is 128 plus 64 plus 8. Take my calculator, I clean up everything. If I say 128 plus 64 plus 8 plus 4 is equal to 204. It means what we did here is correct. Now, you take this one. I took 128. You put 1 here. So if you took 1, you put 1. I took 64. 64 is here. I put 1. I took 8. I put 1 in 8. And I took 4. I put 1 in 4. Anywhere you didn't take, you put 0. 0, 0, 0, 0. Now you write here, this decimal 204 in binary is now all these numbers, you take them and you write. So you start from left to right. Or let's start from left. Let's start from right to left. So we have 0, 0, 0, 0. After that, 1, 1 in front, 1, 1. Then we have 0, 0 again in front. Then we have 1, 1 again. This is the answer. You can copy the screen to make your own notes if you want to. The answer.
Papa Max. Papa Max. Hello.
Yes.
Papa Max. Can you hear me?
Question. Yes, I can hear you.
Say
Yes, ask your
it's a
question.
mayor. It's a may. It's a
Yes,
may.
yes, we can hear you. Yes.
Yes, Papa. I just want to know after finding all the
Okay.
results we are looking for, and then if you want to write that binary, so you have to start from the left to the right.
Yeah.
Papa, can you hear me?
Yeah, you can start from right to left or left to right. But yes, you can
So it's still the same.
yes, we can start from left to right or right. Yeah, it's the same.
Okay, thank you.
Okay, no problem. Okay, I'm going to give you one convert uh 79 in binary. 9 in binary. We have 5 minutes to do that. Okay, I'll be back in 5 minutes. Huh? So each of you must tell me what you find. Huh? So I'll be back in 5 minutes.
Papa Max? Hello?
Yes.
Yes, I found.
Yes, we can hear you.
Yes, I found 0. I start from
So please
the.
paste your
Huh? Can I speak?
and can you paste your answer in the WhatsApp? And yes,
Can I
paste
do
your
what?
answer in the WhatsApp group. I want to see.
My answer in the WhatsApp group. Okay.
Every, yes,
Okay.
everyone put your answer in the WhatsApp group. Everyone.
All right. All right. Hmm.
So everyone, please post your answer in the WhatsApp group. I want to see. Okay, let's do together. So when you have 79, first thing first, what do? You do your table. You always start with 128 divided by 2, 64, and you continue 32, 16, 8, 4, 2, and 1. Now you put your 79 here is equal to what? So you put your 79 again down, and you say 79 is bigger than 64. 79 is not bigger than 128, no. It's bigger than 74, so you do 79 minus 64 is equal to, take your calculator, you clear here, 79 minus 64, 15. Now you say 15. 15 is bigger than 8, is not bigger than 16, no, it's bigger than 8. So minus 8 is equal to what? To 7. Be careful, don't mess up. Huh? If you're not too sure, you use your calculator. Now 7 is bigger than 4. So you take 4 here. Is 3. 3 is bigger than 2. Now 1 minus 1 is equal to 0. So it means I took 64. I took 8, 4, 2, and 1. So 79 is 64 plus 8 plus 4 plus 2 plus 1, according to what I took down here. Now you come here, I took 64, you put 1 here. I took 8, you put 1 here. I took 4, I took 2, and I took 1. I didn't take 16, so I put 0, 0, 0. So now the answer is 0, 1, 0, 0, 1, 1, 1, 1. So this is the answer. So let me check my WhatsApp group who find the correct answer. Sangani. Okay, good for Sangani. Esther. Okay, good for Esther. May. Okay, good. Denise. Okay, it's good. So Denise, don't forget to add a 0 in front. And don't forget to add a 0 in front. Even if you don't add a 0 in front, we always start from right to left. So this one, it will seem like,
Okay, sir.
yeah, so it will same. So we always start from right to left. So even if you didn't put a 0 here, because it's the last one, it's fine. But it's good to add. Okay, we continue. So now it's the same thing. If you need to do the opposite is what? Convert a binary to decimal. It's the same thing. Convert binary to decimal. It's the same thing. So if we ask you convert 111111 to decimal, do again your table, you put your own stuff again. 128, 64, 32, 16, 8, 4, 2, and 1. Now we say this one. You always start from right to left. 1, 1, 1, 1. Okay. 1, 1, 1. 1, 1, 1. Okay, let's say 5 ones. No. 5 ones. So you see, so if you have such thing, it's very simple. You see, if I put 1 here, it means I took 1. So put 1. And I put 1 here, it means I took 2. I have 1 in 4, it means I took 4. I have 1 in 8. It means I took 8. I have 1 in 16. It means I took 16. And you take your calculator and you see, use 4 plus 8 plus 16 equal 31. See? So this number is 30. Yeah, so this one, do it quickly. Convert. to decimal. So do it and you paste your answer in the WhatsApp group. If you find the answer, you post in the WhatsApp group. Okay, Sangani, MA. Okay, let's check. So I'm going to remove here. I remove, delete this guy. I remove here. So we start always from right to left. So here we have 1 in, here we have 0, we have 0, we have 1, we have 1, we have 0, we have 0, and we have 1. And come down here. Yeah, you can start. Yeah, so here 1 is in 1, it means I took 1. There is 1 in 8 and 16, so I put 8 plus 16, and I have 1 in 128. So it means I put, then you take your calculator, you clear everything, you put 1 plus 8 plus 16 plus 128, 153. Ah, Mama May, very good, huh? Brother Sangani, talents, you are good guys. Congratulations. So this is how it works. So this chapter, number system, it's something like that. Now the last part, that is also very simple, is about how to convert in hexadecimal. So after we do that, it's finished. You have a video, we explain the same thing, and you have some exercises that you can do. So very simple. Video is very nice, we do the same thing. So how to convert the hexadecimal, I'm going to show you down here. It's the most easiest. So this table, guys, you should know it. It's very simple. I'm going to show you now. So decimal, you type 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15. You stop at 15. Hexadecimal, 0, 1, 2, 3, 4, 5, 6, 9. And from 9, you stop. and you continue A, B, C, D, E, F. It means if you want to convert F in decimal, it's 15. E in decimal is 14. C in decimal is 12. 5 is 5. 0 is 0. So these two, you know. Binary. Your question, if you have a question, feel free to ask him. Now for binary,
Mr. Max, I can't see the screen. I can't see anything.
Christina, you say,
The
so can you
screen.
hear me, everyone?
Yes. I
Yes,
can
Can you
hear
see
but
my
you.
the
screen?
screen, the screen. I can't
The
see what you're
screen. Okay, let
presenting.
me check.
Yeah,
So can you see now?
not
Can
yet.
you see now? Okay, it's
No,
fine. I'm going to copy. I'll copy that and put in. So can you see now?
no.
Maybe it's your phone because everyone can see.
Mm.
Yeah, maybe
Yeah.
check your screen quickly and we continue.
Okay. Not
Are you
yet.
fine now? Okay, take your time. Else maybe you can log off and log on again. Okay, for the other one, and quickly I will explain to you. Then I will wait for Christina. So decimal, you count from 0 to 15. Hexadecimal 0, you stop at 9. Then A, B, C, D, E, F. For binary, it's very easy. So from right to left, you start 0, 1, 0, 1, 0, 1, 0, 1 until you finish at the bottom. Then with second column, 00, 11, 00, 11, 00, 11. Then 4 zeros, 4 ones, 4 zeros, 4 ones. Then 8 zeros, 8 ones. Done. So I'm going to do here for you. Insert table. Can you see now, Christina?
Yes.
Okay. So when you
It's
have
still the
decimal,
same. I can't see
you
anything.
count from.
I don't know.
Yeah, because everyone can see. So it means. So when you are here to decimal, 0, 1, 2, 3, or until 15. So for binary, you start with 0. Let me put it a bit like that and put it like that. So decimal, you go until 15. For binary, you start with 0, 1. You see, 0, 1, again 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Then here on the second one, now you put 2 zeros. 0, 0, 1, 1. Again, 0, 0, 1, 1. Again, 0, 0, 1, 1. 0, 0, 1. Sorry, I mean 1, 1. 0, 0, 1, 1, 0, 0, 1. Here should be 1, 1. So 0, 0, 1, 1. After that, 0, 0. Then 1, 1. See. Then you add again now. It now 4 zeros. 1, 2, 3, 4. Now 4 ones. 1, 2, 3, 4. Now 4 zeros. 1, 2, 3, 4. Now 4 ones. 1, 2, 3, 4. Now 8 zeros. 1, 2, 3, 4, 6, 7, 8. Now 8 ones. 2, 4, 7, and 8. You see? Now we are done for our binary. Hexadecimal, it will be same. But after that, A, B, C, D, E, and this is how we do the table. So this table, you'll find it in NetAcad. It means if we say convert hexadecimal, let's say 4B to decimal, 4B. This one is very simple. We say 4B, no? 4B. So you divide them, is equal. You take 4. What is the value of 4 in decimal? In binary? This is the value in binary. So you convert first in binary. So 4, this is the value of 4 in binary. B, what's the value of B in binary? You take here, you see, value of B. B is in blue. You see, that's all. Then from here, you do the same thing like we did above. You do your table. You do your table and you put in and you find the answer. Sixteen, 8, 4, 2, then you put all these numbers there. Oh, sorry. And you convert this one in decimal. So I took 1, I took 2, I took 8, I took 64. You take your stuff, you clear 1 plus 2 plus 8 plus 64, 75. You see? So if you need to convert hexadecimal to binary, and you cut them, you take the first one, you check the value in the table, and you put it. You see now? You value and you put it. Now you take the B, you go check in your table, this one, and you add it. So this is hexadecimal 4B in binary. Now, if you want to convert in decimal, you do your table and you find your value. So that's all for today, and you can play around. Okay, let me give you an exercise. Convert hexa 7F to decimal. If you find it, you paste in your WhatsApp group.
Papa Max, before we start, please, I just want to understand somewhere.
Okay.
Papa Max, we start with you ask for 4B, and then we start with the 4 face from the right to the left, isn't? Eh?
So you say 4B. So we say
4B.
4B.
We start in the table. In the table, we start from right to the left, and then the B also we're also gonna take from right to the left.
Yes.
Okay.
Yes,
Okay,
no problem.
thank you.
All right. Okay, no problem.
Okay, what is the question now? Now, where is your question?
Okay, the question is coming now.
Okay.
So now the question is convert this one, 7F. Convert this one to decimal. I'll be back in 5 minutes. If you
Can you put that table please back?
When we finish, you convert also the binary to hexadecimal. I'll be back in 5 minutes. Okay, I'm back. Now we're going to check together. So convert 7F in decimal. 7 and F equal, we put 7, we want to put it in blue. F, we're going to put it in this color. So 7, I check here on your decimal, 7 is 7, no problem, in blue. And F is 15. But the thing is, you cannot just jump from hexadecimal to decimal. You need to go via binary. So 7 in binary is 0, 1, 1, 1, 1, you see? 1, 1, 1, you see? And F down here is all ones. 1, 1, 1, 1. You see? So if you want to convert hexadecimal to decimal, you go via binary first. And this one, if you take your calculator, you do your stuff, you see, this one is 64 plus 32 plus what, you see. So you take your calculator, you clear. So 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 equal 127 in decimal. You see? So when you have hexadecimal, you cut in two. The first one, you check the value in binary first. 7 in hexadecimal, this is the value in binary. F in hexadecimal, this is the value. You do a table and you do your stuff. From right to left when you put in that table of 128. Now we have this one. Convert this one to hexadecimal. It's the same thing. You copy it. You put it down here. You cut in two. So 4, 4, you see. Now, the first one, 1100, you take here 1100 is C. So this one is C. Now the other one, if you put it in blue, all ones, so it's F. So let me check in the WhatsApp group the answers you put there. Okay, May, I don't understand what you did then. Esther, good. Denise, good. Daniel, good. Sangani, good. May, 127 is correct. Christina is correct. Denise, CF, okay. Sangani, CF. Now, if you need to convert this one, this hexadecimal in decimal, so you do your table. So if you do your table normally, you can see that this one is 128 plus 64. 128 plus 64. So 128 is here, 64, 32, 16. So this one is 8 plus 4 plus 2 plus 1. If you do your table properly, plus you clean up properly, took 128, you took 64, then you took 8 plus 4 plus 2 plus 1, 207. And 207. Okay, I'll copy this. Oh, sorry. I paste here. So, and I say equal to 207 in decimal. This one in hexa. So congratulations, most of you, you did very well. This is how it works. So in the NetAcad, you'll see also some videos about that. Video converting always the same thing we did. You'll check them also in the video. I will post what we did also in NetAcad. So please, I want to ask you something. For all your assignment, send it to me at this address, learn networking, because in my personal mailbox I keep on losing some stuff. Learn Networking Academy at gmail.com. So everything in one word, everything in one word, like that. Learn Networking Academy at gmail.com. So please resend all your three assignments. So please send all your assignments, because I need to send to mark them and send to Scalabrini for them to check your progress. Your assignments 1, 2, 3 to the above email address. If you have some personal issues, then you send to my normal email. If it's assignment, please send them to that. I'm going to post again in the WhatsApp group, and that will be fine. So for those who came a bit late, we did check the switches. Early this morning, I did send you a link about switches. Switches, it's layer 2 in the OSI model. And we have two types. We have unmanaged. It's something simple. We don't need to configure. You plug and done. And we have the managed one where we can do some configurations. So this one, for example, is a managed switch. You see, where we have all these. So how much is this one? 5,000. You see, and it's this one I need to buy for us to do our practicals. That's why I'm begging students, please make your payment so that I can save and buy them for us to do some practical at Scalabrini. Scalabrini doesn't have, so it's me, I must buy. So I rely on student payment to pay a switch like that, and all the new cables for us to do some practicals at. Also, once a month, we know that Scalabrini is very busy. All the halls, the venue for teaching are always taken. So if you know a good place where we can also meet once a month, we can meet for 3 hours so that we can do some practicals or some packet tracer or something. If you have a free, nice and secure place in town or around town, let us know. So by my side, I'm still checking at Cape Town, Cape Town, how do you call it? Cape Town, mall, and not mall, community center. Yeah, community center, Cape Town. So I think there is one at Milnerton. There is one in Sea Point. So I'll check if you're available. Well, so which one at least not too expensive. I think it's 200 rand I can pay, so that you can stay once a month. So once a month we meet at Scalabrini for 2 hours, 3 hours, and also if once a month we can check one of these space, we can meet there for 2-3 hours. So I'm busy checking. Okay, So quickly, a quick 5-minute revision for the packet tracer, for what we did. I'm going to show you quick 5 minutes and we are done. While my packet tracer is opening. And this thing we need to book in advance. I did check, we are all taken. People are busy hiring to do. Okay, so when you have your packet tracer and you need to do some configurations. So when you need to do some configuration, it's a quick revision of 5 minutes, then or the Windows 10, or yeah, when you are here, you tap no. So this mode is the user mode. We cannot do much. It's just to view some stuff. We move to the privilege mode. You tap enable. So you can tap EN, and on your keyboard you will see the tab key. On your left side you see TAB, T for Tango, A for Apple, B for. So if you tap EN, and you press the tab key, it will complete. See, so it will complete. You can tap everything, or you can do enable. Now here we are in the privilege mode, and we need to do some configuration. You do the configuration mode, conf T, or configuration terminal. You can tap only conf T, it's fine. You press enter. Now what we know is to change the name. The name, you can tap host name. Host name. Host name is recommend to change the name. I'll call it Scala for Scalabrini. We see the comment to change the name of a host. You see, before it was router, now it has been scanned to Scala. Also, what we check is the banner. Before someone log on your router, you can display a message. So we tap banner, MOTD, it means message of the day. You play asterisk. Be careful. I'm watching you. And you end by the same asterisk. And you press enter. Now, if you want to save your work, if you're in the global config mode, you tap do first. Do, copy, run, start. To save your configuration, you press enter. You can exit to go back to the privilege mode. If you're here and you want to save your work, you just type copy, run, start. See, if you're in the privilege mode, to save, you tap directly copy, run, start. If you're in the global config mode, you tap do first, do, copy, run, start. You press enter. You can exit again. Now you're out of your router. If you want to get in, you press enter, and you see the message of the day is here. Now I'm trying to configure the 3 password. I tap enable, conf T. The first password is before someone reaches here, he must enter a password. Before getting access to the user mode, we should add a password. Line console 0, password you can say CCNA. Be careful, you must write down all your password. If you forget your password, that's your own problem. Write down all your password. And the same way you tap your password is the same way. Password, CCNA, enter, login. enter. You can exit and save your work. Do, copy, run, start. Enter. To test that, who's that? Please mute yourself, please, if you're not. Now I want to log on my router. I press enter. This is the message of the day, the banner. Now you see there is a password here. So the password you created to protect the user mode, you must type it the same way, CCNA. Now I'm in. I go back to the privilege mode, enable, press enter. Before someone reaches this stage, I want to protect it. I want to add a password. There is what we're going to do. Const T, configure terminal, enter. Enable, secret. I type again the same password. I create, and the password you enter here is that password you use, CCNA. You must write down all your password. Password to protect user mode equal. Password to protect the privilege mode equal. Password for telnet equal. You press enter. You save, do, copy, run, start. And you can end everything. You can exit. Now I want to log on my router or my switch. I press enter. This is the message of the day. The very first password to protect the user mode. You tap exactly you entered. And if I'm in the user mode, now I want to go to the privilege mode. I tap enable. I press enter. Now you see there is a password. I enter the password I created. And now I'm in my privilege mode. The other password we need to create is the telnet. Const T, configure terminal, line VTY 0 space 4, password. You can type any password, you must document it. Then you tap login. That's all. Copy to save, run, start. If you want to encrypt, to hide all your clear text password, because if you're here, if I want to view all my configs, I tap show, run. To view all the configuration I made, you press enter. You can see that the host name is here. You press enter. I can see my console password, it's in clear text. My telnet password is in clear text. I need to hide them, to encrypt them. Const T, service password encryption. Service password encryption, enter. So service password encryption will help you to encrypt, to hide all your clear text password here. Press enter. Do, copy, run, start, enter. If I tap again, show run to view my configs, you press enter. I can see that my message of the day, the banner is there. Now, line console to protect, you see it's hidden now. And the VTY password also is hidden. So all these things are just practice. Everything is about practicing. And in NetAcad, if you want to save your work, save in your router, also file, save, and you add your name. For example, save as, let's say, Max, you see, Max assignment, let's say 3, for example. You see, you can see on your desktop. You see, if you close, you say, yes, I want to save everything. This is your assignment here. And you send to me so that I will know that, this is for Sangani and assignment number 3. So that when I download, it's clear for me. If not, you see, the same thing, if you have a Microsoft Word document for assignment, you save your name and the assignment number. All these things are in AutoCAD. If you go here, chapter 2, basic switch and you'll see some videos there. Basic device configurations. You have videos. How to configure the name, the password, and you have a video that will allow you. So you can watch it. Watch it many times. You can filter. You go to course index, top right. If you want to view videos only, you check videos. It will list the videos per chapter. If you want to download your packet tracer, you click on packet tracer, and you download all of them. You save them nicely. Okay, guys, that's all for today. Any questions? Any questions? Please send me all your assignments. Even if you sent before, do it again and send it to me. Or if you save it somewhere, it's fine. Just forward it, send it to me to this address. If you save it somewhere, you send. Hi, Mr. Max, this is my assignment. Assignment 1, assignment 2, assignment 3. You add your name first, Sangani, assignment number 1. Sangani, assignment number 2. Sangani, assignment number 3. And you send. So in one word, learn networking academy in one word at gmail.com. Any questions? If you're struggling, paste in the WhatsApp group. We're going to help each other, as you know. So confirm if your name is here. If you didn't leave early, if your name is here, normally everyone is here.
My name is Dame.
Okay, good.
Amen.
Okay, good. Okay, guys, enjoy your weekend, and we meet again on Monday. So on Monday, we'll be doing chapter. I will be doing chapters 7 and 8. We are very short. We look long, but here CCNA we are very short. We'll do chapter 7 and 8. Have a good weekend and bye-bye.
Bye.